Good afternoon, my dear student. I am Rakesh Abhay from Sunbeam Sun City. My dear, today I am uploading the video on applications of total internal reflection. Right? That is how the total internal reflection is used in the other way round in other purposes. How this phenomena of TIR is used in the different situations. That is, the first is a total reflecting prism. The total reflecting prism is using the phenomena of TIR to deviate the rays through 90 degree, 180 degree, or to invert the image, right? The second is, my dear, optical fiber. Nowadays you all know that our entire telecommunication is based on optical fiber. Optical fiber is a optical device. It is a device, my dear. It is a device which is using the total internal reflection phenomena to transmit the electrical signal to the light signal. That is, from electrical signal and convert it into light signal, right? I will show you. And there are many audio video signals. Your NCERT book has been given, sent through the optical fiber from one end, and it is received at the other end without any loss of intensity in the signal. Okay. And the third use, my dear, you all know that diamond, the brilliancy of diamonds. Now, the brilliancy of diamonds or sparkling of diamond ka chamakna is actually due to the total internal reflection phenomena. The cutters, the manufacturers are cutting the diamond to that edges in such a way that, my dear, every time the light incident at any edge of the diamond, my dear, and the critical angle of that surface of that face is so small that this incident ray, the ray which is incident at any face of the diamond, my dear, will get totally internally reflected. I will explain all this concept while explaining the topic. And the last one is mirage formation. I said mirage formation, my dear. This is optical illusion. Mirage formation is the optical illusion, right? And this we observe in most hotter place, somewhere in desert or in summer month maximum, because for this one condition is that the temperature should be very high to obtain the mirage, somewhere 40 and 40 above, right? And in summer days we observe this phenomena, especially on the highways, my dear. And if the road is of coal-made road, not cemented road, I said coal-made road, because coal-made road, that is koile ke bana hua road, right, is actually, my dear, is too hot as compared to cemented road. So there you will observe this mirage formation. So, my dear, let us discuss one by one all these topics. This is very important, my dear, with an exam point of view. Any one of the things can be asked. All these four are given in your NCERT textbook. Definitely they have given 5 to 10 lines or 15 lines on each topic. We will discuss shortly on each and every topic. But believe me, one common word in every topic is that this all four things which I have written, they are totally based on the principle, on the phenomena. They all use the principle of total internal reflection. Am I clear? So let us start with the first topic, my dear, total reflecting prism. So now, my dear, let's start with the first applications on the total internal reflection, that is total reflecting prism. Now, my dear, the first point which I would like to tell about total reflecting prism, my dear, it is right angled. It is right angled isosceles. It is right angled isosceles. You all know isosceles, that is 45, 90, 45. The opposite angles are equal, that is 45, 45, you can see. It is right angled isosceles prism, my dear. So you should aware that the total reflecting prism is a right angled isosceles prism. It's not equilateral prism has taken that property. This property phenomena to obey of TIR, that is total internal reflection, is by right angled isosceles prism having an angle of 45, 90, 45, my dear. First thing. So always remember that total reflecting prism is a right angle isosceles prism. Okay. Now my dear, how it is using this phenomena? It is using this phenomena in three ways. It is using this phenomena in three ways, my dear. The total reflecting prism is used to deviate an image of a given object. Of course, na, image is for a given object. So to deviate an image of a given object by 90 degree. So here I am writing that this is used as. So first thing I have written, it is right angle isosceles prism, and then in second I am writing it is used as. It is used as to deviate an image of a given object by 90 degree using the phenomena of TIR. It is used to invert an image. It is used to invert an image, my dear. Invert करता है image को. Invert an image. Am I clear? So it is used to invert an image by the deviation through 180 degree. See, here there is a deviation of 90 degree. Here there is a deviation of 180 degree. So to invert an image by deviation through 180 degree. I hope it is clear, my dear. So it is used to, first it is used to deviate an image through 180 degree, through 90 degree, and second is that to invert an image with deviation or by the deviation through 180 degree. And third point, my dear, is to invert an image again, to invert an image without any deviation. Try to understand the second use and the third use. The second use is that to invert an image with the deviation of 180 degree or by the deviation through 180 degree. And third, inverting an image but without any deviation. There will be no deviation. There will be refraction, no deviation. I will show you this all three. So my dear, this is what I have taught till now. That total reflecting prism, which is based on the principle of total internal reflection, my dear, it is actually a right angle isosceles prism. And if it is a right angle isosceles prism, my dear, it is 45, 90, 45 degree processing, right? Now how it is using, for what purpose, my dear, it is to be used, right? Sometimes we have to deviate the image through 90 degree. Sometimes we have to invert an image with the deviation of 180 degree. I will tell you which things are used for which purpose, right? Some of them is using periscope, some of them are using cameras, right? These all things are using, right? We are using all this, right? So I'll tell you where they are to be used. And third one is that to invert an image. Take care of this point. This is very important, without any deviation. So these are the three uses of total reflecting prism, and these three uses of the total reflecting prism is totally based on the principle or on the phenomena of total internal reflection. Now my dear, so let's start with the first use, that is to deviate, how the total reflecting prism deviate an image. How this prism deviate an image of a given object by 90 degree using TIR, total internal reflection. Look at this diagram. So you're supposed to know diagram and you're supposed to know little bit about the writing part of every topics, because exam we definitely ask you this kind of a question. Say, my dear, I have taken the right angle isosceles prism, as I said. This is the prism taken. Now you all know that, my dear, here this is your 45 degree, here it is 45 degree, and here it is 90 degree. You can see, you can call this side as a hypotenuse, you can call this as longest side or face. And you all know that the longest side or the longest face, the longest side or the longest face is called hypotenuse. So this is hypotenuse side. And these are the two shorter faces. You can see here I am drawing A, B, C. So AB and BC are the short face, and this AC is the longest or the hypotenuse face. Why I am saying? Because I will write all this in my explanation. Okay. Now, my dear, assume that here is an object and the name of the object is AB. Look at the diagram carefully. So now what will happen? From the object, the ray of light fall. The ray of light fall, you can see here, it fall normally on one of the face of the mirror. Please see it, the diagram properly. From the object, this is the object, my dear. So this is the object. From the object I have drawn AB. From the object, this ray is fall normally on the shorter face AB of the prism. Normally, you can see 90 degree pe it is falling. Similarly, from here also it will fall normally on this face, you can see, because it is a straight line. So they are falling normally on this. But now, my dear, when they will fall, now they will go without any deviation inside the prism. So from shorter face, they will move inside and they will fall. They will fall, my dear, on the longer face. You can see at, please try to understand, this is the normal I have drawn on this face, because normal is always drawn perpendicular to the surface. तो अगर side ऐसा है तो normal ऐसे होगा. So my dear, this will fall at 45 degree. You can see this will fall at 45 degree. This ray, you can see from the point A, it will fall normally on one of the shorter face. But inside the face, that is on hypotenuse face, this will be incident at 45 degree, my dear. Now what will happen here, since the critical angle of glass, you can say critical angle, because this prism is made up of glass. The prism is made up of glass. So the critical angle of glass is 42 degree. The critical angle of glass, please make a note of this in this topic, that this is a made up of glass. So my dear, the critical angle of glass is 42 degree. And you can see here the incident ray is making 45 degree. It means now here the incident ray, here at this point, the incident ray is greater than the critical angle. The incident ray, the incident angle, you can say, is greater than the critical angle of the incident. And how much is critical angle of this glass surface? That is 42 degree. You can see here. So now what will happen? This ray will be totally internally reflected. Here is the total internal reflection of this ray taking place. And here this is of from which point? Point A. So here I will write A dash, because this is for A. This is for object A, I got A dash. But while coming through the third phase, this is, you can say, first phase, this is the second phase, and this is the third phase. So when the ray deviated, here you can see the deviation of the ray through 90 degree. You can see the deviation of this ray in 90 degree से deviate होकर इधर आ रहा है. But when it's come through the third phase, my dear, right, it is coming without any deviation. It comes straight from the third phase. That is again normally. So what you have learned from this topic is shorter phase पे sir it fall normally, but on the hypotenuse phase it fall at 45 degree. Am I clear? And that 45 degree by which this ray is falling is more than the critical angle of the glass surface, because this is ultimately made up of glass. So here this surface is also of glass. So here we will take, because critical angle I told you is totally based on the nature of the media and a pair of media. So here it is a glass. So glass surface critical angle is 42 degree. Since it is incident at 45 degree, greater than 42 degree, so here is the light is totally internally reflected, and it will be come out of the shorter phase BC without any deviation and form the image A dash. Similarly, my dear, the ray from the point B, you can see, is also fall normally on this phase, but when it will be fall on the hypotenuse phase here, when it will be fall on the hypotenuse phase, my dear, again you can draw the normal here. Again you can draw the normal, you can see, and again here it is making 45 degree. Now this also will be totally internally reflected back, you can see. Am I clear? And it form the image B dash. This is called total internal. Why the total internal reflection is taking place here? Because the angle of incident falling on the hypotenuse phase is greater than the critical angle of the glass, that is 42 degree. And hence here the total internal reflection is taking place. So now my dear, if I draw the image, I got the image like this. Because this is B dash. Because it is B, so it will form image B dash. It is A, so it will form the image A dash. And now it will be like this. You can see B dash, A dash. So it will compare the object. This is your image. And this is your object. So if you compare the object and image, the diagram for this will be looks like. I am drawing here. The object look like this way. And the image is look like this way. You can see with this, you can find that there is a deviation of how much degree, my dear? 90 degree, because if you combine this two, it make a 90 degree angle. If you can see, here it is a 90 degree. So image and object is image deviation of 90 degree as compared to object. I have tried my level best to note it down. So that is why we say that there is a image deviated by 90 degree. My dear, I hope you understood the topic. So now what I have done, that I supposed to write in 2 to 3 lines. So please help me with writing part of this question. So what is to be write under this? So here I am writing explanation. So what is explanation, my dear? A light ray, this is a light ray, am I clear? A light ray from object, what is the name of the object? AB. A light ray from object AB falls normally. What I did, I am writing that. So a light ray from object AB, you can see, falls normally. Tell me yes or no. So falls normally on one of shorter phase. Say, what is the name of that phase? Say, sorry, here object is also the same. So I am removing it out. PQR. Because the object triangle prism also ABC. Say PQ. So simple, a light ray from object AB falls normally on one shorter face PQ, say PQ, and it pass inside and fall, and it, you can say it pass inside and falls at 45 degree and makes the angle of 45 degree on the, it pass inside and you can say and makes an angle of incidence of 45 degree. Am I clear? A light ray from object AB falls normally on one of the shorter face, say PQ. It pass inside, you can see it pass inside and makes an angle of incidence of, of 45 degree, which is 45 degree on किसके ऊपर बेटा, on hypotenuse face, and makes an angle of incidence of 45 degree on which face beta, on hypotenuse face, which is greater than the critical angle, which is greater than the critical angle of incidence of glass, that is how much, 42 degree. Hence the light rays, hence my dear, the light rays, you can see, hence the light rays will be, come on, what happened to the light rays? The light rays will be totally internally refracted. The light ray will be totally internally refracted. You can see क्या हुआ fall होने के बाद. Hence the light rays totally internally refracted. Am I clear? And deviate an image through 90 degree. You can see, and deviate the image while coming through the third phase. I have not written while coming through the third phase. Not writing is not much important. Not much you should write. Don't write much. So only understanding part is that, sir, on one phase the ray fall normally. As this ray pass inside and it will fall on the hypotenuse space, it will fall with the angle of incidence of 45 degree. That angle of incidence of 45 degree is greater than the critical angle of this glass surface. And hence, as soon as this angle is greater, so it will be undergo in a phenomena of total internal reflection, my dear. So here is what I have written, that a light ray from the object AB, now you can see a light ray from the object AB falls normally on one of the face. You can see this is one of the face, and at that one of the face I have taken PQ and it is falling normally, clear cut. Am I clear? And after falling normally on one of the face, my dear, it will be incident on the hypotenuse face. You can see it is incidenting on the hypotenuse face with the angle of incidence. I can say it pass inside and makes an angle of incidence of 45 degree with on hypotenuse space, or you can say it is incident on the it pass inside and incident on the hypotenuse space with, है ना, ये लाइन भी लिख सकते हो, and it pass inside and incident on hypotenuse face with angle of incidence as 45 degree, which is which is greater than the critical angle of incidence of the glass, that is 42 degree. I hope this is enough to understand, my dear. So this is your first topic, that how the total refracting prism, by using the phenomena of TIR, how they deviate the image of an object through 180 degree. So this is one topic which I have explained you, and this is the diagram, my dear. Here it is 45 degree because normal is like this, because face is like this, so normal is this. And as soon as I draw the normal, I came to know that this incident ray and this incident ray both making an angle of 45 degree on the hypotenuse face. So that's what I have written. A light ray from the object AB, once again it is last, a light ray from object AB falls normally on one of the shorter face, because PQ and QR are the shorter face and PR is the longer face, hypotenuse face. So it will be fall normally on one of the shorter face. It pass inside without any deviation. यहाँ कोई deviation नहीं है. You understand the word deviation, घूमना. यहाँ there is no any deviation. It pass inside, you can say it pass inside without any deviation. Here you can write this word. It pass inside without any deviation and incident on hypotenuse face with angle of incidence as 45 degree, and my dear, which is greater than the critical angle of incidence of the glass, that is 42 degree. 42 degree is the critical angle of this glass because it is a glass prism, and hence the ray will be total. Here you can see this is the total internal reflection of the rays. Am I clear? It will come out through the third face also without any deviation, you can see here. But then you will observe at the end that the image is deviated. The image object is like this and the image is like this. You can see my finger, the object is this, image is this, my dear. It is making an angle of 90 degree. So it deviated the image to 90 degree. That's all from my side for the first topic. Now I will go for the second topic, but before that take a pause, write it down. This is one explanation, write it down, then I'll go for the next two explanations. Now let's go to the second total reflecting prism used. That total reflecting prism is used as the second point, the second one, to invert an image, right, by deviation of ray of a ray through 180 degree, and then I will draw the conclusion for total reflecting prism. See, every topic of the prism, reflecting prism, my dear, you have a common word, and that common word I will write at the end. First I will explain, right? So now let's to invert an image by deviation of a ray through 180 degree. And what is the diagram for this, my dear? Look at it. Here I have taken the prism. Say the name of the prism is PQR. And now you can see this is the longest side or longest face called hypotenuse face, and these are the two shorter face. You can see this is shorter face, even this is shorter face. See, you understand the things properly. Well, and say I have taken the ray here, the object here, say the name of the object again AB, and the light ray from the object AB will fall normally on this. You can see same thing, it is falling normally but this time it is falling normally on the hypotenuse face. See, earlier when it was deviation through 90 degree, that time it falling normally on the shorter face and falling at 45 degree on the hypotenuse face. Now what happened? It fall normally on the hypotenuse face, the longest face. See? So there is some conclusion you are supposed to draw for this prism at the end. Let me complete all the things. So now, my dear, Here this ray will be go on to the shorter phase without any deviation, as it was going in the earlier case to the longer phase without any deviation, and it suffer. Of course, here I can draw, my dear. Here is the normal, no doubt it is 45 degree, 110%. Again the concept of 45 degree, and it suffer the first total reflection, internal reflection here. It suffer the first TIR, pahla total internal reflection. There is 2 TIR for one point. So it suffer first TIR from one of the shorter phase, and then it will fall here. Again I can draw the normal here also, my dear. So here also it is making an angle of, you can say, 45 degree, and it's go here. So it suffer the second total internal reflection. You can see it suffer the second, because this is the incident ray, this is the normal on this surface, है ना, ये normal है. Even this is the normal ray. I wanted to show you कि 45 degree it is now. It is making 45 degree on shorter phase. Earlier it was making 45 degree on the hypotenuse phase. So ये कंपलसरी नहीं है कि नॉर्मली शॉर्टर फेस पे ही गिरना चाहिए और हाइपोटेनस पे 45 डिग्री पे ही फॉल होना चाहिए. ना, रॉन्ग कंक्लूजन. Conclusion is that, sir, it will fall at any phase normally, and when it will go inside, that at inside phase it will fall at 45 degree, and then at inside phase, as soon as it fall at 45 degree, of course, my dear, the glass critical angle is 42 degree, and there it will take a participate in the part of total internal reflection. So I will draw that conclusion. Similarly, my dear, here also this ray will fall normally here. It suffer it will go here. Here also I can draw the normal. Here I have written shorter phase. Here also I can draw the normal like this. Again it is 45 degree. Here it suffer the first TIR. Here I can draw the normal. Again it is 45 degree, my dear. You can see, because this is the normal ray. This is the normal ray. And here it will go like this, that it will suffer the second total internal TIR B. So here I am getting A dash, because this is A. You can see this is A. So here it is A dash, and this is B. I write B dash, and here I can see the image is inverted. This is image inverted, and this is your object. You can see the diagram of this question, my dear, that how this is happening. So now, my dear, here what can I write? What is my explanation? What is my explanation in this point? A light ray from object AB falls normally, you can see, falls normally on hypotenuse face QR. You can see object AB falls normally on the hypotenuse face QR. Am I clear? I hope it is clear. And suffers first total internal reflection. First total internal reflection. You can see AB suffer the first total internal reflection. A is suffering air and B is suffering air from the one of the shorter phase. And second internal reflection, A is suffering second internal from air and B is suffering the second internal from the second shorter phase. So here you can see, and suffer first total internal reflection from one shorter phase, and again it suffer second total internal reflection from the other shorter phase. It suffered a second total internal reflection, you can see, from the other shorter phase, and the name of the other shorter phase is, now my dear, you can see the PR is the name of the other shorter phase. And the final, you can see this is final. So the final rays emerges out from the hypotenuse phase. Am I clear? You can see the final rays. The final ray is coming out from where? From the hypotenuse phase, and we observe the image is inverted, and we observe the image is inverted with the deviation, you can see deviation, gaya aise, this is all deviation, yahan deviation, then yahan pe deviation. So this is the deviation of going this way and coming this way. You can see kitne ka deviation ho gaya. So with the deviation of 180 degree. That's all. This is the writing for the second part, my dear, and I hope you understood. So what I wanted to say from first and second concepts, that it is not necessary that the light should fall normally on the shorter phase, because earlier I said the light was falling normally on the shorter phase, but now, my dear, the light is falling normally on the hypotenuse phase, and inside phase it is falling at 45 degree. And the same concept, since it is 45 degree, glass ka critical angle is 42 degree. So since 45 degree is more, here it is suffer internal reflection. Again here also when it fall, here again it is falling with 45 degree, this ray. That did become incident ray for this surface. But again when it is falling at 45 degree, again the glass surface has 42 degree ka critical angle, again it will suffer the TIR. And therefore we said it suffer the first TIR from the one shorter phase, and other TIR, the second TIR, from the other shorter phase. And it will emerge from where? The ray will be emerged out from the hypotenuse phase. Am I clear? And when it will be emerged out, we will observe that the image is inverted with the deviation of 180 degree. So my dear, please, I will give you the conclusion at the end after dictating all the three topics. So let us write this, and then I will go for the last topic with respect to the total reflecting prism. Now my dear, let's go for the last use of the total reflecting prism, and the last use of the total reflecting prism is to invert an image without any deviation. And my dear, such prism are called erecting prism. Please take care, this prism is also called erecting prism. The second topic which I have discussed, that inverting an image with deviation of 180 degree, are called poroprism. They are called poroprism. And this is called erecting prism, where the deviation does not take place, but still the image get inverted. So I repeat, my dear, the earlier topic where I have inverted the image with the deviation of 180 degree are called poroprism. So in exam can be a question, explain poroprism. I will give in writing also. and here where the image is inverted but deviation does not take place, no deviation, are called erecting prism. Now look at what is the diagram for this prism and how it invert the image. Say my dear, I have drawn the diagram like this. You can see the shorter face and you can see the hypotenuse face. So here this is your hypotenuse face, and I am writing here PQR. Here it is 45 degree, here it is 45 degree, and here my dear, here it is 90 degree. You can see. Now my dear, here in this question, what will happen? This is the object. So the name of the object is AB. So the light will incident here. You can see the light will incident here from the object AB at certain angle on the shorter face, at certain angle on one of the shorter face. Here certain angle is made by the incident ray, and they incident at certain angle on the shorter face, my dear. From here they refract. This refract here. This is called refraction, my dear. Here there is a refraction takes place. The refraction will be takes place from here. So here it undergoes in a refraction at this surface, and as soon as it fall on the hypotenuse face, my dear, again I can draw here. This is the normal and here this is the normal. Here it is making an angle of 45 degree, and now this will be refracted here. Totally internally reflection takes place here. This is TIR. This ray will be reflected here. You can see both the things together coming. You can see the level also. And now my dear, again this ray is TIR happening here. This is total internal reflection taking place. But then here, as soon as it reach on the other shorter face, again from here the ray get refracted. Here the refraction is taking place, and this will refract here. The ray get refracted, and here this is, you can see here this is A coming this way. So this is A dash, and this is, you can see here it's coming as this way. So this is your B dash, and the image is inverted like this. You can see the image got inverted, and in this case what happened, my dear, the top incident ray, this ray is called top. The incident ray which is at the top will emerge from the bottom of the prism. Will emerge at the bottom. You can see this is bottom. And the incident ray which is at the bottom is come at the top. Here it is at the top. So please take care. The incident ray which is at the top, right? When it will be emerged at the bottom, and the ray which is at the bottom, when it will emerge from top. You can see, and the images are inverted without any deviation. Here the refraction and TIR takes place. Refraction from first order, refraction from second order, and from hypotenuse faces, my dear, total internal reflection took place. So I hope it is clear with my diagram that refraction was taken from this first shorter face, and then before emerging also the refraction was taken from after emerging, while emerging again the refraction was taken from the other shorter face. But total internal reflection was taken from the hypotenuse face. You can see here and you can see here. So my dear, this is the diagram for the third question, and I hope you can write this answer also. So let us start writing the answer for this. So what about writing, my dear? How will you write this? So you can write about this way. That is called explanation. So the explanation for this question will be, how will you go for explanation of this? The first point, the incident ray the incident ray from object AB suffers first refraction, the incident ray from object AB, you can say here, the incident ray from object AB falls at certain angle. The incident ray from object AB falls at certain angle on shorter face PQ. The incident ray from object AB falls at certain angle, right? It falls here also at certain angle on shorter face PQ. Am I clear? Or you can say the incident ray from object AB incident at certain angle also, falls के जगह पे incident at certain angle on shorter face PQ suffers refraction. Here there is a refraction, my dear, so it suffered refraction. Am I clear? And falls on the and incident on the come on बच्चों, hypotenuse face. Am I clear? The incident ray from object AB, you can see incident at certain angle on shorter face PQ suffers first, you can say suffers first refraction and incident on hypotenuse face with angle of incidence greater than the critical angle of glass, that is 42 degree. So it incident on hypotenuse face. जब incident हुआ hypotenuse face पे तो कितने का angle बनाया? So with angle of incidence greater than critical angle of glass, that is 42 degree, it incident here, right? That is 45 degree पे incident हुआ है. So it incident on hypotenuse face with angle of incidence greater than the critical angle of glass, that is 42 degree. Hence, it will totally internally reflected from the, hence it will totally internally reflected from the, come on, from the hypotenuse face, totally internally reflected from the hypotenuse face and suffer second refraction when it emerges out from other shorter face, and what is the name of shorter face? PR. You can see. So my dear, it will totally internally, internally reflected from the hypotenuse face and suffer second refraction when it emerge out from other shorter face PR. Am I clear? In this case, my dear, what is happened? In this case, the light ray does not suffer. In this case, the emerges light rays or the emerging rays, in this case, emerging rays does not suffer any deviation, deviation, only the incident ray, in this case the emerging rays does not suffer any deviation. So हुआ क्या है? Only the incident ray at the top, emerges out from the bottom of prism, and vice versa. In this case, emerging rays does not suffer any deviation. The rays which are there, you can see them still there like this. Object भी ऐसे जा रहा है, emerging rays भी ऐसे ही जा रहा है. So they have not suffered any deviation, my dear. Only the incident ray at the top, the incident ray which is at the top will be emerging from the bottom of the prism, and vice versa. That is, the incident ray which is at the bottom will be emerged from the top of the prism. Am I clear? And the image obtained is inverted. Such prisms are called errating prism. And my dear, this prism are use of this prism uses in binoculars, projection lantern, projection, you can say projection camera also you can write, but the answer is projection lanterns. So in projection lantern, you all know lanterns. So in binocular, in projection lanterns, this are the uses for this, my dear. The earlier was called poroprism, and first one was used in periscope. I have not given you, but the first that is getting an image which is deviating through 90 degree, that is used in periscope, my dear. So this is all about, my dear, this topic. So ultimately, what is total reflecting prism, my dear? What is total reflecting prism? It is only a right angle isosceles prism. Only this much. I think it is a right angle isosceles prism in which I will give you that explanation. But my dear, I hope you all understood. So in this case, the incident ray from object AB, you can see, is incident at certain angle on the shorter face PQ. First point is incident at certain angle on the shorter face PQ. Suffer first refraction. It suffered first refraction here. And incident on hypotenuse face with angle of incidence greater than the critical angle of glass, and hence it will totally internally reflected here, you can see, from the hypotenuse face, and suffer the second refraction from the other shorter face, you can say, and suffer second refraction when it emerges out from other shorter face PR. It is a second refraction. Am I clear? In this case, the emerging rays, where this is the emerging rays, there does not suffer any deviation. Only what is happened, the incident ray which is at the top emerges out from the bottom of the prism, and vice versa. That is, the one which is at the bottom will emerge out from the top, and the entire image gets inverted. Such prism are called errating prism, my dear, and their use are in binoculars and projection lanterns. Whereas the second one was called poroprism, where the inverted image we are obtaining by deviation the rays of 180 degree. Usko poroprism bolte hain. And the first one which I have done, where the image deviated through 90 degree, are used in periscope. Please take care. The first case where the prism is used to invert and to deviate an image by 90 degree are used in periscope. And the second one, where the image get inverted by deviation of 180 degree, are called poroprism. and this prism was called erecting prism, using in binoculars and lanterns. So here, my dear, I will stop this part. So let us go to the next topic, which is called uses. Matlab, what are the advantage of this prism on mirror? My dear, this prism is a reflecting prism. Try to understand. So if it is a reflecting prism, what is its advantage on mirror? Because mirror is also a reflections. Mirror also used for reflections. So if there is a mirror already, why we are using the prism for reflection? What is the use of this reflecting prism? How it is more useful than mirror? So the question is advantage of this prism over mirror, right? So please write it down and then I will go for the next one. So my dear, now let us discuss what is total reflecting prism, because I have discussed all the three cases of total reflecting prism. So what is total reflecting prism, and write its advantage over mirror. Over mirror, and the mirror is a plane mirror, because plane mirror is used for reflection. We are knowing that. So what is the advantage over plane mirror, right? So what is total reflecting prism, my dear? Now I hope everybody know the total reflecting prism. The total reflecting prism is a right angled isosceles prism. So if it is isosceles, I can write 45 degree, 90 degree, 45 degree, in which a light ray falls normally on any of its face. Am I clear? The total reflecting prism is a right angle isosceles prism, 45, 90, 45, in which a light ray falls. क्या होता है concept में? Sir, light ray falls normally on any of its face, any one of its face, I can write. So normally on any one of its face, and incident on inside face at 45 degree. So light ray falls normally on any one of its face. पहले तो एक falls करेगा any one of the face पे, and then incident on inside face at 45 degree. You can see my first diagram, second diagram, even third diagram. So it will incident on inside face at 45 degree. That is, yeah, you can say which is greater. This 45 degree is greater, which is greater than the critical angle of glass, which is greater than the critical angle. I am taking glass because prism is made up of glass. So here the material is glass. So we will interested in critical angle of glass. So which is greater than the critical angle of glass, that is about 42 degree, and hence these rays suffer, and hence these rays suffers total internal reflection. I hope it is clear. So what is total reflecting prism? The total reflecting prism is a right angle prism, right angle isosceles prism, 45, 90, 45, in which a ray, you see any diagram, this is the conclusion. This is the conclusion I have drawn from any three diagram, that a light ray falls normally on any one of its face, and then this incident on inside face at 45 degree. Am I clear? You see any diagram? Since it's incident at 45 degree, this 45 degree is greater than the critical angle of glass, which is 42 degree. So क्या होगा? Angle of incidence is greater than critical angle. कल से पढ़ा रहा हूँ. So what will happen? The rays suffer total internal reflections. Now advantages. Advantages of total reflecting prism. Reflecting prism over mirror, over plane mirror. Advantages of total reflecting prism over plane mirror. The first point, my dear, I hope you all know that in total reflecting prism, the entire light will be reflected, totally reflected. There is no loss of intensity in the reflection. Am I clear? But in the mirror, my dear, there is a loss of intensity. So here the first case is that in total reflecting prism, there is no loss of intensity of reflected light, reflected rays. Whereas in plane mirror, there is some loss of intensity of reflected rays. So in total reflecting prism, my dear, the first point very easy, there is no loss of intensity of reflected rays. कोई loss नहीं होगा, total rays will internally reflected, there will be no loss of intensity while reflection taking place. But in plane mirror, my dear, there is some loss of intensity of reflected rays. Second point, my dear, the property of reflection in total reflecting prism is permanent. मतलब total reflecting prism has a prominent property of reflection. They will reflect only, sure they will reflect. But mirror, my dear, if mirror is tarnished or reflection property of mirror is affected by tarnishing, you can see the scratches or something is formed on the mirror. If mirror is not coated, you can say tarnishing is related with the coatation. So my dear, here I can write the reflecting property. The reflecting property, my dear, in the total reflecting prism. The reflecting property in total reflecting prism is permanent. डिस्टर्ब नहीं होता है. रिफ्लेक्शन ऐसा नहीं है कि टोटल रिफ्लेक्टिंग प्रिज्म रिफ्लेक्ट नहीं करेगा. बट मिरर इज द प्रॉब्लम, माय डियर. मिरर, प्लेन मिरर, if it is tarnished, then the reflection property is not a permanent in case of mirror then. Am I clear? So here it is an important word. The reflecting property in total reflecting prism is permanent. However, it is affected by tarnishing. In case of plane mirror. Tarnishing, you know, that's relation in coatation, that's coating. Am I clear? If it is not polished or if it is not coated properly, or if its coatation is lost, if it is tarnished, am I clear? Then the property of reflection by the mirror is lost. It will affect. जितना करना चाहिए उतना reflection of plane mirror नहीं करेगा if there is a tarnishing, my dear. Am I clear? But in total reflecting prism, the reflecting property is permanent. And third, my dear, you can say, in mirror, my dear, I have done many numericals. Number of multiple images are formed in plane mirrors. In plane mirror, my dear, the multiple images are formed. Am I clear? And because of that multiple images when formed in a plane mirror, some of the image is faint. Am I clear? Some of the image is faint. Am I clear? But in total reflecting prism, reflecting prism, no multiple images are formed. No multiple images are formed. No multiple images are formed. However, in case of plane mirror, there is a multiple, there is number of, you can say. However, my dear, I hope you are understanding the last point. The last point is very important one, that in total reflecting prism, the no multiple images are formed. While in the plane mirror, the number of multiple images are formed and some of the images are faint. Am I clear? So, in case of plane mirror, there is number of images are formed. Images are formed in which some images are faint in addition to the prominent image. In addition to prominent image. In addition of prominent image. So this is the three uses, my dear, you can take care that in total reflecting prism no multiple images are formed. But in case of the plane mirror, you have no need to write so much, but you should read everything. But in case of plane mirror, my dear, there is number of images are formed in which some images are faint in addition to the prominent images. कुछ prominent image है, कुछ real images है, but some of the images are prominent means which is bright. And the images are, some images are faint. So the one which is bright can be only observed by the observer. Na? So they are prominent for the observer. But my dear, some images are observed as a faint also in the case of plane mirror. Whereas there, in case of total reflecting prism, there is no multiple images are observed. So these are the three uses you can take over for the total reflecting prism for over the plane mirror. Take care of this. The first use is, sir, in total reflecting prism there is no loss of intensity of the reflecting light or reflecting rays, whereas there is a loss of intensity over here. The second, that the reflecting property of total reflecting prism is permanent, but it will be this property, the reflecting property is that affected by the tarnishing in the case of plane mirror. So by tarnishing this will be affected in case of plane mirror. And in third, my dear, the no multiple images can be observed in total reflecting prism. So if there is no multiple images, there is no question of faint image over a prominent image. But in case of plane mirror, my dear, there is a multiple images, that is, there is a faint images in addition to the prominent images. I hope it is clear. This is all from my side for the total reflecting prism. This is a brief study. Now any question can be asked with this. Please answer the questions properly. Thank you. Jai Hind you all.